Hi again, I'm Mr. Hawkins, Head of Science at Thomas More Catholic School in Purley. Before I start today's session, I just want to remind you of the NHS advice as the Easter holidays come very close to us. Make sure you stay at home to protect the lives of others and to help those who are working hard for us in the NHS. Don't be tempted to go and see your family. The spread of this virus is very fast, and we need to make sure that the time you're missing from school is for the right reasons and that this disease doesn't spread any further. Okay, so let's get started. Enzymes. Today's success criteria is, first of all, understand and be able to answer what is an enzyme, explain how enzymes work, be able to appreciate the difference between the models of how enzymes work, understand what affects the rate of enzyme substrate reactions and how to identify those from the graph. If you use this as the basis and you want to go and do some additional reading or research, I would suggest you go and look at your GCSE core practical for enzymes, as most exam boards include one enzyme-based reaction. So let's get started. What is an enzyme? Enzymes are biological catalysts that speed up the rate of a reaction within a cell. They are made up of these amino acid chains that form a globular protein structure. So if we look over here, we have pepsin, which is found in your stomach. And pepsin tends to break down, well, does break down proteins. What you'll see is that each of the different colours represent the amino acid chains, and they're all folded together. They have slight, weak intermolecular forces that hold them together, and that these forces are very small differences in positive and negative. So the structure looks quite complicated, but really it's just a simple set of chains all folded together. So a couple of key points to remember. I obviously didn't make these, I've cited the source at the bottom. Looking at this first diagram here, this is the classic and perhaps the simplest way to explain how an enzyme works. The enzyme here is the Pac-Man-like structure, and the substrate is obviously in love with our enzyme here. As you can see, the substrate fits perfectly into the active site. The substrate is the molecule or the molecules taking part in the chemical reaction. So the substrate comes into the enzyme and something happens, or the enzyme breaks it down, or it builds it up, or it does something to the substrate. Over here, we have, in this diagram, I'll try and use the laser so not. Here we have the enzyme, this is the substrate and the active site. The substrate fits into the enzyme to make the enzyme substrate complex, and they break up and a product is made. What you'll also notice is that this model, if you look carefully, includes, I'll just wait for it now, once the substrate bonds to the enzyme, you see there's a slight change here, and that's a transitional state, something I want you to look at in the next slide. What I'd like you to do is to look at the two key theories on how enzymes work. The first of this is lock and key, and the second one is the induced fit model. Okay, I think this diagram helps explain the differences quite well. What you'll see is that the lock and key model was the classic, okay? You know, for example, that your key works on your house. Your friend's key wouldn't work to unlock your front door. It might be able to get through into the holes of the lock, but it wouldn't be able to twist and make something happen. That's the idea of lock and key. The substrate fits perfectly into the enzyme's active site. As a consequence, they meet and a reaction takes place. In this case, something was formed from these two substrates. Induced fit is slightly different. The induced fit suggests that the substrate doesn't fit perfectly into the enzyme's active site. There is a slight variation between the substrate and the active site, and that effectively the enzyme, when it bonds to the substrate, there's a slight change in the shape of the active site. What that does is that improves the bind to from the enzyme to the substrate, and in effect there's a transitional state. So it's not just simply like lock and key, substrate comes in, fits perfectly, reaction takes place. In the induced fit model, the enzyme slightly manipulates its structure to get to the end result. I would also like to say there are loads of other points on this that you could have, and the website I've cited down here is very good. It's got a very good comparison. So let's move on to what factors affect the rate of enzymes. Temperature, pH and concentration are perhaps the key three. I would also mention that surface area can be cited sometimes, and perhaps it's something you want to look at. I haven't addressed it here. So go away now and research the effects of changing the above, so one of the three, on the rate of enzyme reactions. Okay, so temperature. I'm sure you found out that temperature affects the rate of the reaction. In fact, up to a point, as you can see here, the rate of reaction increases as temperature increases, up until you reach an optimum temperature. Now, optimum means best. So here, the optimum temperature is, we obviously don't know because there's no scale, but for most enzymes in the body, it's around 37.5 degrees. That's the temperature the body is regulated at. Above this critical temperature, enzymes start to denature. Okay, what that means is there's a change to the globular structure of the protein. Remember back to pepsin earlier. And that change in the structure excuse me, means that the active site is no longer able to bind to the substrate, therefore no reaction can take place. And as you can see, it falls off. And when you reach a very high temperature, the rate of reaction is 0. So, pH. pH also affects the rate of reaction. Now, each enzyme is unique and works within a specific pH range. Pepsin is found in our stomach, so obviously it's working in quite acidic conditions. The optimum pH for pepsin here being 2 degrees. The optimum pH for pepsin here being pH 2, obviously not temperature, sorry, my apologies. Amylase, on the other hand, works best at a pH of 7, which is found in your mouth. It helps start to break down sugars that you eat. So the key points are that pH is different for each enzyme. Changing the pH causes a change to the active site shape, and that the charges within the structure, the small differences that hold the globular protein together, remember, are affected by the different acidity or alkaline nature of the conditions, which, effectively, if you have an extreme change in the pH, you will completely denature and usually permanently damage the enzyme, meaning that it can no longer work. The last one is concentration. Now, enzymes obviously work best when there's a lot of substrate concentration available. So if there's another example of this would be if it's going on with supermarkets at the moment. If all the people going into the supermarkets are the enzymes and the toilet rolls are the packs of toilet rolls are the substrates, and if there's lots of toilet rolls, everyone will be able to pick up a set and put them in their trolley. If there's no substrate there, well, the enzyme's got nothing to work on. And as you can see from this graph, before I move on, if you can see from this graph that the substrate concentration up to this point increases the rate. But what you will notice at that point, it plateaus, it levels out. So you need to be careful here and look carefully at the graphs. Now, whether it's substrate concentration or enzyme concentration on the axes, it doesn't really matter. So in this case, when the enzyme becomes saturated, i.e. there's so much substrate there, the enzyme can't, every enzyme's being used, there is a plateau, there's no increase in the substrate concentration. So you could continue. Another way of looking at this is going back to our, let's go back to our supermarket example of toilet rolls, is that you then only allow 3 people in the shop, but they're only allowed to pick up 1 pack of toilet rolls each, but you have 10,000 packs of toilet roll in the supermarket. Well, there's only 3 shoppers, so there's only 3 people who can actually pick that substrate up. So the idea is that you could continue to add more toilet rolls, but if you don't add any more people, there's no way they can take them. So you just have to be careful and just look at the graph and infer from the graph what the question's asking you to do and what's going on. So let's just review our success criteria. We now understand and are able to answer what an enzyme is. We are able to explain how enzymes work. We now are able to appreciate the difference between the 2 models, the induced fit versus the lock-in key. We are able to understand what affects the rate of enzymes in reaction terms, in terms of their pH, temperature, and concentration. And hopefully some of you have gone away to look up the GCSE core practical on enzymes. Thank you very much for listening. I just want to finish with that message. Stay at home, make sure you keep yourself safe, and have a good Easter.